So welcome to our talk on the Debian of Data, which we hope is something that's not only a project, but well, is at least increasingly becoming reality. So Rufus has come here from Cambridge in the UK. So let's give him a warm welcome.
Okay. Can you hear me okay? Yeah? It's working. That's fantastic. I must say I'm phenomenally impressed, having run a conference myself, smaller than this one, at the organization here. I think it's absolutely amazing. But then I guess what happens when geeks are in charge. Okay. I hope my voice is okay. I've been rather ill, which is why I'm wearing the scarf and stuff. I had flu, but I'm better now. I flew in yesterday. I'm going to talk to you. I just want to start off by saying, who am I? Who the hell are we? The foundation is something called the Open Knowledge Foundation. It was founded 5 years ago, 5.5 years ago. It's a not-for-profit, it's kind of charitable, and our aim is to promote, create, and disseminate open knowledge. By that I mean content, data, genes to geodata, stats to sonnets. Now, one thing is we're a community. We're organized around a set of projects and working groups, a bit like Apache. People can come to us and start projects that live there. And we basically 3 principles, which is open knowledge, meritocracy, and tolerance. So how does this lead into the Debian of Data? So I'm going to start off talking about what do I mean by open, because this seems a really boring thing. And I think everyone here knows what I mean by open source, right? Put up everyone. Who doesn't know what open source means? Everyone knows, okay. Who's heard of Creative Commons? And have you ever heard people say stuff to you like, my stuff is Creative Commons? Now, the thing is that statement isn't very meaningful, right? When someone says something's open source, you mean it has one of a particular set of licenses. And in particular, you know you can share that stuff with other people. But when someone says something's Creative Commons, it doesn't mean very much to you, right? Because those Creative Commons licenses are incompatible. You can't mix often stuff under one Creative Commons license with another unless you know which Creative Commons license. And so one thing that we kind of say when we say open data or open knowledge, why this matters is the whole dream here is that we can share and reuse other people's stuff, that we're going to make this massive patchwork quilt of data. And to do that, we need to know that we can reuse other people's stuff freely. So it's really important that we actually are clear about what we mean by openness, even though it seems really boring. So freedom to access, to use, reuse, and redistribute. Okay, so how's this relevant? Right, because except for some really hardcore, we don't care about openness or freedom necessarily in some sense in itself. Why do we care about it? Why? Why do we care about it? What is it we want to do? I don't know, who here recognizes this phrase? It's very English, but anyone? Right. Where's the phrase from? Girls' song. Exactly. What we want, what we really, really want, is to create and use information. Right? That's what we really want to do. We don't give a damn, really, about whether that data's licensed or unlicensed. It's that we want to do shit with that data. Right? We want to take that data and we want to know what our representatives did. What did they vote on? What are they doing with our money if we pay taxes? Or I'm a researcher on global warming. What is the temperature history? What is the temperature data? What are the projections for the future? How are they computed? What are the models? Whatever we are, we want to create and use information for really important ends. But specifically, what do we want to do? We want to get lots of this data and we want to plug it together, right? And this is so blindingly obvious, but I just want to emphasize what we want to do is we want to get data and we want to plug it together. So I'm going to give an example here of why stuff might be interesting, because it's really dull just talking in abstract, right? So this is a data set actually that comes from the US. Weirdly, a lot of data comes from the US. Can anyone guess why a lot of my examples come from the US? And it's not because I particularly like the US or not. Can anyone guess? Right, the federal government data is public domain, and also they don't love PDF. right? A lot of people out there, particularly the government, love PDF. And what's bad about PDF, right? Everyone here knows what's bad about PDF is you can't get stuff out of it very easily, right? But even here, I'll give an example here, actually, in a moment of where you can even obfuscate stuff quite well in TXT. But so what this is a story, actually, a really interesting historical story, and it's about US wheat production. Now, you wouldn't think this is so fascinating, but I was speaking just a year ago. What was going on a year ago? There were these massive spikes in commodity prices. Everyone was saying, what's going to happen? What are people going to eat? Now, this is about, you can't read this, but it starts, each of these graphs starts in 1860. And by the way, if I speak too quickly, please tell me, because I have a tendency to speak too. I speak too quickly. Okay. So every time I speak too quickly, you can start, like, I don't know, humming or something. Okay. So these start in 1860, and they run to 2008. And the starting one is output, right? This is the amount of wheat that you're actually getting in bushels. And you can't really read it on the axis there, but there's essentially, this here is about the First World War, okay? And there's a tripling in output between 1860 and the First World War. Now, what is that? What happens in the 1860s? The Civil War ends in the US. And people start, all those films you see about cowboys and stuff, that's people going westwards. The Transcontinental Railroad opens in 1865. By the way, site of one of the great financial rip-offs of all time, the Transcontinental Railroad, basically. But leaving that aside, these people go out west and they start farming. So there's this huge opening of the prairies, and that has massive consequences. For example, everyone in Europe, if you're a peasant or a landowner, bad shit happens to you. Because what happens is wheat production in the US triples. It drives down the price of wheat in Western Europe. So there's a whole alliance between aristocracy and peasantry in Europe as a result of this in the late 19th century. It's called the Great Depression in agriculture. In the late 19th century, it has big political effects. Okay, but what's really interesting here is that yield, and we can tell, yield has not gone up at all. There is no increase in the amount of corn you're getting out of the same bit of land. This is all about just farming more land, right? But at some point, that stops happening. At some point, basically, the amount of acreage, which you can see up here, which is being farmed, you can really see the tripling in acreage, flattens out. This is around the First World War. There's no more land to farm. That's it, okay? You've run out of more stuff you can go and do. And so what happens? How is it that output keeps rising? And this is the story here, which is this incredible revolution, the Green Revolution, which is driven by technology, basically. It's pesticides and it's nitrogen. This huge increase in yield, a tripling in yield again, like a massive thing, that leads to this great increase in output again, despite the fact you've run out of acreage. And this is the reason that price, though increasing a bit, stays fairly level here. And this is not, by the way, in real terms, but this is 2008. This is when commodity prices started to take off. So you can actually see a huge amount out of this data story. But getting that data isn't easy. Because, I got this data, I'd like to do lots of other things like it, like normalize price, have it in real terms. So to give you one example, I was also interested in unemployment. I actually am an economist as well. And so I said, I want unemployment, US unemployment. You think it's pretty standard data. So you go and dig around on their website. You finally locate this, and look, they have text as well as PDF. Your heart leaps. Is there anything noticed anything about this text file? Right? I mean, it's actually almost, I'm exaggerating a little bit, almost artificial intelligence getting these headings out of there, and they're human recognizable, but they're really damn hard to automatically extract. I mean, they really are. I've written the code, and it's not easy. In fact, I gave up, and I just wrote them out by hand. And, we get help for things like, it looks really nice for humans having all these dots, but, why couldn't I have a CSV file? So a whole bunch of effort has to go into getting this file, extracting it, and after some amount of effort, I have this. I have a CSV file, which you can see being printed out here. And you have to do this a lot. Most data files you want, you have to go and do this. I've created and parsed a whole bunch of data which I can use. What about you guys? Here's what I can do, and guess what's happened here? This is another wonderful story, right? 15% unemployment at the outbreak of the Second World War. Look what the Second World War did to unemployment in the US. I mean, there's nothing like a war and all that war production to kill off unemployment. And I mean, guess what happened in the 80s? Does anyone know what happened in the States in the 80s? What Reagan did? Massive remilitarization, like massive military spending. Who knows what will happen now, huh? So, you know, and you can really see the story. So this is the 70s. This is when this Congress started, that big depression of the 80s. And this is where we're back at now. We don't have 2009 in this, but we're back at 10% in the US. So this is a huge amount of history. But so again, this has been extracted from that data set. But that's great, but how do we scale? I mean, this is all great for me, but I want to take that data, interact with all kinds of other things, and I can't do it all, right? I have a limited amount of time. It's only me or my corporation or whatever it is. So how do we scale? I mean, what we really want to build here is large-scale data infrastructures. We want to build stuff like operating systems, but for data. We want to build big, relatively, bigger than any individual or any corporation. So how do we do that? How do we build complex things? One answer is we use lots of labor. These were basically the tallest, at least, man-made object till the 19th century, for about 3,000 years. We think they employed about hundreds of thousands of people at a given time, though not particularly oppressively, in fact, it turns out. So that's one option, is we can just use lots of people under some central direction to build these things. But it's actually quite a simple thing, a pyramid. I mean, it's big, but it's pretty simple. But what about the Empire State Building? When we build bigger stuff, it gets more complicated. Is the architect telling that guy exactly what to do? Probably not. It gets too much for one mind. So how do we deal with this? We divide and conquer stuff up, right? We break down complicated problems into small parts that I can deal with. I can deal with getting US unemployment data, and you can deal with getting inflation data, or, you know, GDP deflators, or the price of wheat. We want to break data down into chunks that can be individually managed, packages of stuff. Now, this is really, in a way, revolutionary. Most systems, when they're small, get built in one way. When you have an early computer, one team builds everything. You know, often you just rebuild the OS for your particular system. You rebuild the set of libraries. And the problem is, when you break stuff up, how do you put Humpty Dumpty back together? Right? If you just break stuff up, if you just atomize it, you're a bit screwed, because maybe you just have a broken egg. You've broken everything up, which is great, but you've got no way to put stuff back together again. What do we mean when we do about packaging? What is all the effort? When we talk about Debian, do Debian actually write any code? But relative, yeah, you're right, they do. But relative to the packages they use, what's the contribution of Debian in terms of pure source lines of code relative to the stuff they use? Anyone have an estimate? 1%. Maybe even less, I would guess, compared to the Linux. Huh? Much less. So you've got this whole project that doesn't actually create any, in theory, new material. What do they do then? What is all that effort about? Plugging stuff back together, right? I mean, making sure all this stuff generated by different people actually works together in some way. Like a lot of effort gluing things together. So it's about the packaging and putting things back together. So there are two different models about how you can do this, and I think this is really important. So one is, we have kind of a one ring to rule them all. Yeah, you have one centralized system, and you know, we don't want to speak names, but let's say Microsoft or Google. All the data will end up in their system, or all of the code ends up in their system, and they make sure it works, and they give you the APIs, and they give you the formats. And it's probably closed, and most data is currently like this. I mean, let's just go through. Think of finance data. Almost all finance data is closed. Like Bloomberg, Thomson Reuters, anyone with big data sets about finance, it's closed. You have to pay, it's proprietary and closed. You even think of science. You think about prices. I mean, hey, would anyone like a price history of all the stuff we buy? Can anyone name a data set where that's openly available? What about sales? Really crucial. I mean, I'm talking about economic stuff because that's where I come from, but most major data sets you can think of are currently closed and proprietary. And it's a kind of one ring to rule them all model. Everything will come in. No! The revolution should and will be decentralized. So what does that mean? What it means is we don't have one person in charge in some sense. Remember, that's the many mind principle. The best thing to do with your data will be thought of by somebody else, not by you. So we want a model where small pieces are loosely joined. We want to break stuff up. We want to let individual people make stuff and not have to comply necessarily with central authority. So that means sharing and separation. I can do stuff without having to worry what you're doing. We don't need some central architect telling me and you how we should coordinate and how we should do stuff. But it requires openness. This is really crucial, right? For this model to work, it's really hard to do if you have to go and seek licenses from everyone. If every time you want a piece of geodata or postcode data or whatever, I don't know here in Germany, you have postcodes, right? You have these 5-digit codes. Is that openly available? Anyone can get it and reuse it. You don't have to sign any license agreement. It's hard to find, but you found it. And what form is it in? Text, a text document. And how does it give you long lats? I mean, what use is the postcode unless it resolves to something else, right? What do these list of postcodes give you in Germany? Right, and if you get the data out of Google Maps, who've paid money to some gazetteer to give you long lats out, is that free or not? Would you be worried that one day the people Google have paid money off, because remember, Google don't care because they're just licensing, but the people who've given it to Google been paid some money will come after you. It's really unclear, it's why it's really important to be clear, but we require openness to do almost all of this stuff if we want to do it as a community and we want to do it properly. We need openness, it's really essential. And almost no one's put a license on their data currently. No one even thinks about it, so it's essential. So how do we make it happen for data? How can we do this? So go back, how many people here haven't used some flavor of Linux? Normally, the other place I talk, I get very different responses to that question, unsurprisingly. So there's something really miraculous about this. We should almost, it's difficult in this hall, but get down on our knees and worship. Because there's something truly, truly extraordinary about this. Because most of the people who've at least packaged up this stuff have never even met. And this is probably, in fact, I would put a big bet on it, the thing running on your laptop is probably the most complex artifact we have ever created, that humanity has ever created, in terms of the number of man-years, the complexity of conception that it encapsulates. This is the most complex artifact we have ever made. And yet, at least in running these distributions, many of the people who are putting it together have never even met, may never have spoken to each other. And imagine they did, how horrendous it would be. It's the kind of thing that does cripple. You feel very large corps when they try and do this thing eventually, which is that they subscribe to a more centralized model. So amazingly, we can build something really complicated in a very decentralized way. In a way that means when I can say, I want X done, and 35 packages that all have some dependency between them are installed magically on my system, and at least most of the time work, right? So this is truly miraculous, and it's something that we take for granted too often. So what goes into making apt work? What goes into making it tick? There are two things. There are two things that go into it. First, APIs. right? First is that when you install like libc and you install Firefox, and like Firefox needs to talk to libc, they are the right version, they've published a bunch of documentation that means there's a bunch of calls you can make. And remember, this is not always the way. Going back a long way, code was not really written like that. People would just write their own, they wouldn't have redistributable libraries. You wouldn't have some common library, you just write libraries for your system, literally. This took a long time to happen in code. That you actually, libc gets used many times, not just by one thing, if you like. But the other thing that Debian is doing, if you like, or apt is doing, is distribution. The APIs isn't actually done by Debian, it's done by the other people, right? What Debian does is bring that stuff together and get it onto your machine, like download it and shove it somewhere on your disk in the right place, and give it a name and make sure it's compatible. Right? And guess which of those are harder? Which do you think is the harder, the first or the second? The second. Okay. I mean, I would definitely say the first is hard. And why is the first hard? Because the first isn't a technological problem most of the time. And I have to say, often there's a tendency, and I have this as well, of this community to think that technology is the solution to lots of problems. But one of the points is that what's really hard about APIs, I think, is that they're a social problem because they're about agreeing on something. They're about things like not breaking other people's stuff by just randomly changing yours when you feel like it. They're about like social commitments, they're about shared understandings. Like how much effort goes into naming stuff? I mean, I don't know other coders out there, but I always find naming things is like one of the hardest things I do, naming things well. And that's partly about social shared conceptual understanding that we have. So they're domain specific. Geodata isn't the same as genomics. People won't agree on stuff in the different areas. It requires coordination, which is hard. They're hard to plan in advance, and you normally get them wrong when you do them the first time. And so things like RDF, people come to me and say, what about RDF? Isn't it solving all of this? Well, what about schemas, guys? And do you notice how like most schemas are wrong in version 1? And then even though there's always a dispute, and like, I mean, at the moment I do some RDF, and there's always like 3 different schemas often for a particular area. You know, maybe Dublin Cores made it 5 years in. This stuff is really difficult. So I'm going to completely ignore it because it's hard, and I can't solve it. Only particular individuals will solve it by trial and error and agreement. Like, it's building a platform. That's what ultimately it's doing. So we're focusing on the distribution part because that's easier, I think. Right? Because I don't have to get into this question of what schema have you used or what standard have you agreed on. I can just say, well, what we're going to try and do is this crude packaging. If we take stuff and wrap it up with some metadata, and we do it in a form suitable for automated upload and download, and we think about really interesting questions, such as, what do APIs mean? Data's big compared to code, right? It's much bigger than code most of the time. So often you want to install a package which is just represented as an API, not as something on your system. Now, how do we cope with that well? How do we mimic dependencies on APIs? And we register it so it can be found. Those are things we can do now. So this is, if you like, the vision of what we kind of... CKAN has now been around, which is the thing, part of the thing behind this, for about 2 years, and we planned it about 4 years ago. And there's like 3 bits then of this system. You can forget the bit on the left. One thing you want is a registry. You need to know where to find stuff, what it is, right? But in data, you want to separate that from all the actual stuff, right? Because the stuff is massive most of the time, or it can be massive. And even, you know, we're not for profit. We don't have hundreds of terabytes. We're not Google, right? So we want to separate that from the storage. So you want storage and you want a registry. And the storage problem, by the way, really seems to be an open problem for this community, which is how do we do effective distributed storage? We've messed around, I think people from Tahoe are here, we've messed around with Tahoe and other things, but you know, you could store on archive.org, but how do you do good distributed storage here for open data stuff, for large-scale storage, which people can contribute to from the community? But we built CKAN, we built a registry, it has an API, and it has a Python client, other things, and it has apt-get, it has a thing which talks to that registry, and therefore can also talk to storage. So the idea is you can register things, this is a way of bootstrapping things, you can register things with a pointer to where their payload is. You have a registry separated from the storage because you you're not going to be able to upload all this data all the time. So you need to be able to point outside to some other system. And so, if you like, this part of the system is built, and we're piggybacking on other stuff like archive.org. And if people have suggestions for ways we could build distributed storage that we could use or other people could use, I'd really like to hear them. So what does it actually look like? This is what it looks like. There are currently 766 registered packages as of this afternoon. It's kind of wiki-based. One thing to notice is that people dealing with data aren't all coders. So the web user interface really matters here because people need to be able to register data, and we need it to be versioned. So this is like a version data model here. So anyone can edit the packages at the moment, though you can have owners and you can shut stuff down. You have recent changes. And it's like fresh meat, CKAN, or gems, or something like that, but for data. It's been running for 2.5 years. And you can register stuff on it. And here's a particular package. In fact, that package I talked about earlier, the USA employment, I actually put this up there today, and I just had to type data package register the name of this thing, and it was there. So here it is. And it has links, has a download URL. We're actually replacing that. One of the things people tend to do with data is they don't tend to put it in a single file. They put it in multiple files. They do all kinds of crazy stuff with it that makes it much harder to deal with, right? Anyone here done packaging? You all end up putting stuff in some nice tar, some nice zip. I mean, also, by the way, that doesn't work so well for 2 gigabytes of stuff. It's a kind of problem. So a lot of open questions here that I think are really interesting also for hackers, like how do we do this? How do you scale well for large data sets? How do you integrate other things such as torrents? So, oh yeah, and another thing I should just mention is this make an inquiry using is it open. Lots of people give out data, even people who mean it to be open and they don't put a license on it. Most people here, I bet you, who make open source stuff, do you put a license.txt in your distribution? Anyone do that? And you probably don't even read it. You maybe copy it from somewhere else, right? Or from your other project that you did. Because it's really boring and unimportant to coding. I mean, it is, but it's also essential. So if you start doing data, shove a license.txt in there, for God's sake. It's really important. Because without it, we're going to start making inquiries to you using is it open. So then the thing is, the last part of that is the apt, the kind of command line tool and if you like, library that you can use. So this works, what I'm showing you here. I'm not just showing that you can install data package right now and fingers crossed this should work, right? I ran it this afternoon. Does anyone know the poem, The Wind Hover? I am talking to a German audience, I'm aware of that. The Wind Hover, by a guy called Gerald Manley Hopkins. It's a beautiful, amazing poem in English, if you like that kind of thing. It's a really amazing guy. He was a very troubled Catholic chap. So anyway, interesting guy. But there's this data package demo which happens to contain this poem, and you can get info about it. You can do this obviously with all of the 766 packages on CKAN, and you can install it. And when I say install at the moment, what does install mean for data at the present? I don't know. So what I mean by it is I download and unpack it somewhere. But the biggest thing to do with this, right, is dependencies. The biggest thing we want to do this because that's what makes componentization work. That's what makes divide and conquer work, which means you can do something and I can use it without having to go in and just install it. At the moment, people do what I call the lump of data model. You just download more and more stuff onto your machine, normally from Excel spreadsheets, and munge it into some big thing that you want, and then you never give it back out because there's no way to do that easily. So this is how you give it back out now. When you've done that, all you need to do is create a very brief metadata.txt, and you can just do data package registered dot to CKAN, and it will be up there. So I'm going to just hand over to my colleague for a moment, Daniel, who's head of the OKF chapter in Germany here. And what we're trying to do to internationalize and kind of decentralization, like eating our own dog food, right, is this. So I'm just going to hand over to you for a moment, Daniel.
Thanks for the talk. Yeah, hi everybody. My name is Daniel Dietrich. I'm very happy. Is that on? It's on, but we need to. Okay. So I'm very happy to join this fantastic project and help in the internationalization of CKAN. We actually just launched a German version for CKAN today. As you might see on the right, the translation is still a bit buggy, and there's not a lot of data yet. I actually just added the very first package today. From my point of view, the big potential in CKAN is that while using a decentralized system, you can find, it actually works as a register where you can find open data. And that can include open data from science, and it can include open data from public service and politics. So the idea of launching a German version of CKAN is to get one register where people can find, search and hopefully find data from these different areas, which is open. We will have actually a small symposium on the Semantic Web Day in Leipzig, which will take place in May 2010. And on this event, we will actually invite lots of people from science community to join, helping this become a real valuable registry where you can find these data. Also, something that you didn't mention is that CKAN is used for managing the metadata from the data.gov.uk website, which will be the open government data website for the UK. And this is also some aspect that I particularly find very interesting, because at the same time I'm the chairman of the German NGO Open Data Network. So we're trying to promote open government and open data and transparency here in Germany. And I think while starting this registry for open data, which includes science and public sector and politic data, it gives us a strong argument to say, like, hey, wow, this is already used by UK government to manage their data, so hopefully we can convince German politics to also open up their data and link it to this kind of register where it can be searched and found on one way, on one side. I'm not going to talk technically about any of this, but one thing that appeals to me very interesting is, if you think about science, there is a lot of scientific data published in Germany under public domain, but how to find it? Like, if you're a student or a researcher, you would have to go to Google and try to search open data, or you would have to go to all the different universities to try to find their data that is published openly under public domain. But that's quite a hard thing to do, and I think specifically for this register can help boost not only the publishing of open data, but also the use, the reuse, the redistribution, and finally the overall the value that our society can use it. And well, that's basically from my side. I would like to encourage all of you guys that if you want to participate and help this register to grow, we have a wiki that can be found right there. So it's wiki.okfn.org.de, which is trying to set up a community to help support this project. And there you will find a link to a mailing list. And this is, as I said, just starting, and hopefully by the end of the year we will have a big success already on this.
Ooh, sorry, Dan. Yes, as Daniel said, in fact, CKAN.net in the UK and the system is being used as part of the UK's data.gov.uk effort, which is this effort to start registering UK government data sets and making them open, getting them out there into the public. And I think one thing I want to mention here is, if we think code is big, right? I mean, the role that code plays in society has got larger and larger. The number of people it employs, its significance, everything from our tax submission system to our computers are now run on it. Data, I think, is going to be even bigger. Data is going to be even bigger than code. I mean that both commercially. I mean, I come from the UK, so financial services are both loved and hated, right? But what are bankers essentially doing, particularly investment bankers? They're essentially simply transmitting information. They are taking money in, and they're trying to reallocate it, in theory, to good investments on the other side. They are simply trading data or information. What is insurance doing? I mean, it's transferring risk, but it's also deciding about what risk is. Data is everywhere, and data will be big business, it will be big for society, it will be big for democracy, and it is the next big frontier. Right now, governments are thinking about this, and also big corporations thinking about it, and also we should be thinking about it. And I don't, by the way, I should be very emphasized, we're big. I like big corporations, I like small corporations, but at the same time, we certainly cannot trust monopolists to always proceed in our best interest. Right now, most of the information infrastructure of our world, from social networks to search engines, are run by companies which are close to being monopolies, and from whom we have no guarantee that they will act in our best interest. It is essential, I think, to us as citizens, that we ensure that the basic infrastructure, just like the basic infrastructure of the net is open, the basic information infrastructure, the basic data infrastructure of our society is open. So I'm going to conclude by saying, I think this is the start of the Debian of data. We're way behind code, but we can learn from a lot of what code has done. And we can also face really interesting new problems about how we deal with large-scale stuff. How is data different from code? How is it the same? How do you do, everyone here, who's used a version control system? Right? Has anyone ever tried coding when they first started out without a version control system? It was painful, right? Not that painful. But is there a version control system for data? How do we do data diffing? I mean, the moment data diffing amounts to dumping your SQL, your CSV, your Turtle, your N3, and running text diff on it. There are seriously interesting problems here that need to be solved. So this is the start, and we need data package managers are wanted right now. And the thing I would emphasize here, particularly at a congress such as this, is that data and code are becoming one. What is the difference ultimately between your data file and your list? Between the code that parses the data and the data itself? Much of the difference is disappearing. If you hack code, you are hacking data, and at some point, if you hack data, you'll hack code. If you remember, and I'm sure many people here have read Gibson, his vision of cyberspace was not about code. It was always about these great mountains of data, not mountains of code. Thank you very much.
So, you know the drill about queuing up at the microphones for questions.
So you mentioned semantic web and RDF a little bit in the passing, and it sounds like your model is more a data by value, whereas my impression of linked open data is a pass by reference. Could you enlighten me on why your approach is it actually different? I mean, enlighten me why you feel it's more important or better?
Okay, a really great question. So, I mean, just one question. Who here knows what RDF is? Okay. So about 50%. So just, so in answer to you, first explain maybe to the audience that doesn't know, RDF is a format. So who here has used an Excel file? Everyone has used an Excel or a CSV file?
Oh.
Right? But it's a way of structuring the data on disk, right? And RDF is, if you like, another way of doing that, and then you can build schemas on top of that. So you can say, this column contains dates, or whatever, right? Or much more sophisticated. So I would say what we're proposing here is entirely complementary. And by the way, we do quite a lot of work with the semantic web people. So I would say RDF is about the APIs. It's about the schema. We're at the kind of a level behind that saying, we don't care what you've got. If you've got a bunch of Excel files, we can point at that. If you've got a bunch of RDF as triples, we can point at that. We don't get in at this point to the question of how you should format your data, whether it should be Excel, CSV, RDF. In general, I'd have a preference often for RDF or something more structured than Excel, but we're really Catholic. We're not getting into that fight, right? So that's what I would say is we're kind of a step above. Just like you don't care whether you're getting a program that's in C or in Ruby or in Python or in... Do you see what I mean? Does that make sense to your question?
It kind of, except that I feel that, I mean, because you're using the apt model all the time, which implies that you're going to download the data
onto your disk,
whereas linked open data is more a reference model.
Right, okay. So the answer to that is to say, when I said the really interesting thing with data is you don't always want to install it on your machine. You don't want a terabyte of data on your machine. You want to point to the API to that terabyte or to the RDF node for that data point or the Sparkle endpoint for that. So one thing that I think is definitely the case is that people want to install data packages which, if you like, are shells. They're a representation. Just as, if you like, in a slightly odd format, Debian or other systems have this when they have mock packages that stand in for any substitute. Here we want a shell that points to something remote. So we encapsulate, like we have packages which don't point to a tar.gz, but to a Sparkle API, right? But, okay.
So do you understand you correctly that it's basically more about searchability and putting metadata on existing data, not so much about finding and creating the data itself? So it's more like the meta directory of data out there.
Okay, yes and no. So, yes, you need things, and you need two pieces of metadata you never get through Google. So you need license information, and you need a download URL.
Yeah, I was thinking about there are directories like that out there, especially the scientific community has them and uses them. PubMed comes to mind.
Yeah, bioinformatics.
I guess if you put them in a more centralized position, you probably get more value out of them because they're not data islands.
Sure. But I think the second thing, so you're absolutely right. So for example, we know quite a lot of people from the Sanger Institute, which do a lot of genomic work. And there are kind of things like there where they already have these things for like annotating the genome. We're starting to have listings of here are all the places, people annotating this particular protein on that particular protein. But I think one of the things I think is also about building an ecosystem. So the point going back to Debian was it isn't just a registry. What it starts to coalesce around it is people who do this small intermediary role of the packaging, when you say of metadata, and checking putting it in some format. So be it, converting to tar, I don't know, it's in CSV, but it needs to be in RDF or something like that. So I think that's the other crucial point, is you need to coalesce around it some standardization on formats and other things, and creating the actual coherent set of stuff.
So you're also about filtering or combining data?
Yes, and doing some curating, maybe we say, curating.
Okay, thank you.
I have a suggestion and a question as well. I think you could save yourself tons of work by just porting or whatever the metadata of Project Gutenberg.
Gutenberg, okay.
Where texts where the license, where the copyright has expired, are collected. And, you've told us about 760 packages. Well, using that would raise that to a few tens of thousands of packages, I think. Maybe that could raise exposure. And the second thing is, I wonder what your actual scope is and how well the whole infrastructure scales. Because when you say data, it's anything between huge data sets of terabytes of data or a single picture or image. So where does it all end? And when you're getting down to data sets that are really that small, you cannot all, well, I think you cannot all register and maintain it as humans, but rather you should, it should be done by machines. And at that point, you do nothing else than, for example, Google. And, well, I'm old enough to know web directories, and I know search engines, and, well, we both know where that story ended.
Sure.
And this seems like a dead end to me.
Okay. Really interesting. I mean, are you finished? I didn't know.
Yeah.
No, so I think really a good question to ask and to kind of critique. So I guess one thing is about, the first thing you said was like, are we reinventing the wheel? Like people have done this. So one answer is data package basically directly rips off, if you like, Debian, at least the metadata format and R and other ones, and also Python, the Python package index. I mean, our original idea was just to clone the Python package index pretty much directly. So we kind of have tried to minimize the reinvention of the wheel there, in that we're trying to do what already exists, but port it to data. You gave this question about Project Gutenberg. I don't know, I've actually done some stuff on a project we call Open Shakespeare. I mean, I like Project Gutenberg. I don't know I'd want their metadata format over, let's say, Debian's, but I take your point that we should use something that exists. Your bigger question was about it just being automated. So my question I'd put to you back, and I don't know if this should become a dialogue, but is, it would seem to me that code is even more attractive to this than data, right? You know, if you're saying there's automated tools that will just do this stuff for us, why do we have all these human package managers around? Why is it that code, automated code, packaging up code doesn't happen already? And the same point goes, you're saying a question of how do we decide on scale? Our question at the moment is we wouldn't ask people to register individual photos or an individual book. We want something relatively coherent. But your question is a really good one. How do you decide? And the same problem happens in code stuff. People have to say, is this a single file worth putting on in Debian, or does it have to be Firefox or the Linux kernel? And there's some things which are a single bash file, you know, which lets you do word counts or something, and there's some stuff that's millions of lines of code. And so exactly the same question comes up. And it comes to a question of judgment is my only answer, which is why I think, at the moment at least, humans are definitely present in this process. And if all we were doing was a registry, I think that would be a bit pointless, I agree with you. But the hope is that we're building an ecosystem around that of people who maintain the data, or at least make sure it's registered and updated, and who use it to automatically install in their system or whatever. Do you see what I'm saying? It's not just Google plus a tag.
Yeah, that leads to another problem. Because when you have decided on that, even then the question remains that this whole directory is just an imposement of a hierarchy upon arbitrary data. And from my experience from Debian and apt and the like, I can say that hierarchy structures work well for maybe a few thousand packages. But when you're coming to tens of thousands of packages, this doesn't work at all. And there's this internal project within Debian, deb tags, for what we've seen, tagging packages. But even if it were complete, which it isn't, nobody tells us really how to really search for these kinds of things, how to combine different tags to really find what you're looking for. And these are all unsolved questions, and all you're doing right now is another directory of stuff that already exists in a kind of taxonomy that you have thought up on the spot, more or less. And I don't think this can in any way keep up with the dynamic nature of data today, data in the future, and I think only machines have a realistic chance to have a shot at really categorizing data, making data accessible in any meaningful way.
Okay, so I kind of agree with you, I think, maybe, which is that I'm pretty sure a hand-maintained list is maybe not going to scale in 20 years' time. But, I mean, do you know, what would you propose right now we did instead? So one question I have is, there is an API. So if you have some cool bot that's going to do all this stuff for us, you can do it, you know, either you can just forget about CKAN altogether and just pull all the stuff out of it and put it in your system, or start your own instance and code it however you want. The code's all open, start, you know, mymachineInstance.ckan.net or whatever. So my question right now is, when your machines are going to do all of this, give me it right now, and I'll use it instead. But I don't, when you say machines will do it, it's kind of, I'm not clear. It's like, what do you do instead of Debian right now? You're saying it's not working.
In my humble opinion, you should just build the infrastructure to make existing information and existing metadata more accessible to tools like that.
Right. Okay. But I mean, a lot of the time, I should probably end and move on. Sorry. Okay. I'll come back. We can talk afterwards. It's been very good.
So you mentioned that we should, when we upload our databases, we should insert a license.txt there. So could you elaborate a little on what kinds of licenses are there and what is the legal foundation for them?
Right, yeah. Okay, so data licensing is an exciting and probably fairly dull topic for this audience. But so the answer is Open Data Commons, which is actually a project the Open Knowledge Foundation which is as a home for now, although it was started before that. Open Data Commons provides two licenses. One is a public domain license, and one is basically an attribution share-alike license. It's in fact a license that's called the Open Database license, which OpenStreetMap are actually voting about moving to from their buy share-alike. So those opendatacommons.org. There is also CC0, which is a public domain license from Creative Commons, waives everything. But those, you know, in the open source world, those are it. There's also an attribution license being drafted by Open Data Commons right now. To be frank with you, just putting, at least, even if you just put a license.txt saying, I hereby waive all rights, or I hereby waive all rights except you better say that it was me who did this first, or whatever, is better than putting nothing. You know? It's still a license. I mean, it's not great. So that's what I'd really recommend, is just put a license.txt. You know, at best, just grab the public domain dedication license, or the open data license, opendatacommons.org, or write your own.
Rufus, thank you. I like your idea very much. And you said that you extracted out of that text file, you've written a piece of code that extracts the data and puts it into a CSV file. If that piece of code, which normally would be sitting in your machine only, if that was included to sort of convert the original file into a usable file, that would be a major step forward in my opinion. So I think making that available would be very good. The second thing is, you said linking, for example, the street names from the German zip code file to the OpenStreetMap coordinates or something requires that the naming is the same. So your dependency mechanism would identify files which have the same names for streets in both files, and sort of identify files that match in that respect. That, again, is something that I don't see existing today, and that I think your project can contribute, which is a step forward. Thank you.
Thank you very much. So the answer is, on the first point, we've done it. That is a public URL. In fact, actually, you've got to replace SVN with HG and get rid of the trunk, because it's moved to Mercurial. But if you went to hg/data/bls/that, you will get the code that does the parsing. And unfortunately, this is the problem with chopping up stuff. Here is this page, and at the bottom of this page cut off is an extra field which says source, and it has information about the Mercurial repository. Because at the moment, the crudest thing we do with the data, because by the way, data changes, particularly for government data, and this is very interesting, government data tends to get updated and changed. So for example, budget projections. And you just don't have the old version available anymore. It just gets written over, and that can be very interesting data to look at what's changed. So at the moment, we tend to cache all the data and just shove it in Mercurial or our versioning system, but we would like something better than that, because that doesn't scale for bigger files, really. We do it for only up to 1 megabyte, and then you get a really big Mercurial repository. Okay, sorry, one more question.
Well, first, I'd like to say thank you, because I think it's a great idea. I had a question about the sources. I mean, there's one crucial difference between code and data. Code is self-contained. I mean, if I take the source of any program on Debian and read it, I know everything I have to know about the code. I don't care if it's written with Vime or Emacs or on Windows or Linux. I know everything. But data always refers to something real, which isn't the data, which is the object the data is describing. And that's what the method with which it was acquired makes the value of the data. And I think it's a big problem, because any archive of data is a big step, but to use it scientifically, for example, you must be sure that well, it's the government that gave the unemployment figures, or it was calculated, or it was approximated by someone. And all of this is interesting, but is there any way to make really clear what was the protocol to acquire the data?
Well, okay, so you make an interesting point. So first is you think there's this code-data distinction. I mean, it seems to me that many of the things you talked about at the end, like the approximation, would have been done in code, probably. And the points you have about understanding what you're doing is very important, be it for data. You know, when you use data, you need to think where it came from. But, I mean, at least I'm an economist, and I know many people who do stats in economics who maybe, you know, maybe including myself, when I'm using some stats routine someone coded into some library, I don't go and read the source code and check whether they made some misapproximation. I trust them. And you're saying there's this question of trust for data that's really crucial. And I think you're right. So one issue here is, and I don't know what the answer is, one thing is we have an author and a maintainer field. So one is who first wrote this data, and who's kind of cleaned it up or messed around with it. So there's a distinction there. And that's one way to deal with it. I mean, ultimately, the other thing is giving out the source code. I think the point is most data can be given out with the code that generated it, or at least prepared it, and the data itself. And that kind of refers to the previous gentleman's question. I think it's really important we give out the code as well. I don't know if that answers your question perfectly, but
Okay.
thank you.
Actually, I had two questions, but the first one is already partly answered. The thing is, source code is actually a kind of an opinion. Yeah? So like Firefox is a solution for a problem, and I can say I like it or I don't like it, and I use another browser. But data is about truth. Yeah? And so we should look for who published the data, and do we believe him that that's the truth? Because there are agents everywhere who have an interest in defining the truth. Yeah. So this raises, in my opinion, a huge problem of authenticating the data, as well as authenticating the script that parses it.
Yeah, so I think you've asked a really good question about provenance, basically, about authority and provenance for data material. Where does it come from, and how do we verify it came from, and how do we verify it's not been changed? I don't know whether this problem is how different it is in a really technical sense of, i.e. data's come from A to B, has it been changed? It's kind of like, has my MD5 checksum, is it still reliable, or, you know, that kind of question. I think a deeper question is almost a social question, though, which is about how do we trust the government when they publish unemployment figures? And I have to be honest, I think one of the biggest things is about publishing the source code. If we could see the way they do the approximations for unemployment, or the way people do climate change calculations, if that data is truly public, and at least we can authenticate it did come from this source. You know, they've got it on their website with an MD5 hash, and I can check that mine has the same MD5 hash. Then I've got a pretty good hope that I've got their data. And then it's a question of me being able to understand and check their data and calculations. So I think there are two things there. One is social, about our trust in institutions and our transparency of those institutions. And the other is a technical question about literally has data been modified between A and B in some way? And it gets, I do think data is going to be more complicated in code because people are going to do very complicated mashups. So you're going to end up with some query that you're seeing the results of on some web page that maybe is 200 databases. And then there's going to be the question of how do I check the provenance of each of those kind of queries? How do I know someone isn't messing somewhere along the way with that, which is a harder problem.
Yeah. Well, it doesn't clear it all the way, so I have to look at the mashup and try to decide what kind of trust level I assign it to it. Well, okay. The other thing is, as you said, I don't want a terabyte of data on my machine, so if there is a terabyte data set, there seems to be necessary kind of API that creates a subset to my specifications. Yeah? Yeah,
yeah. I mean, I think this is probably the most interesting area to think about, which is what does packaging or representation. The crucial point about the packaging allows us to do dependencies, allows us to do handout maintaining a particular data set to a particular person and know that they'll be dealing with it. You know, this is, but then how do we represent it on my machine? You know, that's what you're kind of asking. How do I say things like, I want to install, I don't know, let's think of some big set like the Tiger geodata set, which is about 5 gig. It's not that huge, but it's fairly big. How do I install some representation of it or some slice of it? Now, one model, which kind of Amazon maybe are taking, which is you come to the cloud, we'll ensure there's one copy of this data set somehow sitting in the cloud, and you can kind of access it from your machine. So that's one solution. It's quite a centralized solution. The one I would favor is somehow representing that package and doing what you're saying, which is be able to install on your machine a representation, which is really talking to an API, and which you talk to almost like a local copy, but which is ultimately proxying or providing some slice of it to you. But I think that's a really interesting question at the moment of how we do packaging for data in that way.
Okay, thank you.
Thank you.
So I'll try to be brief after I've been told to. A few very quick points to the provenance problem. I wonder whether, or let me just put it as a statement, to the provenance problem, there is a bunch of folk in the semantic web crowd who are basically trying to figure out the technical part of the problem for RDF when used as a data format. Right now, that work is going on.
Named graphs and so forth.
Named graphs, and search for provenance XG on Google and you'll find it. And I'll leave it to that and corner you in the break.
Okay, thank you. Okay. No response needed.
So
I should shut up.
I'll have to close this session because the next speakers are coming in, the next persons are coming in. I don't think we can hold them. So let's thank our speakers once more.